So when we're learning about logarithms, it's important to make sure that we talk about what the number e is, which is Euler's number, and the natural logarithm. All right, this is just another type of logarithm. It's another number, but it's a unique special number. So we should talk about it at least a little bit. Take a high-level math class. They'll spend a ton of time in this because it's actually a super important number. It's like pi. It just appears. All right, it appears in problems and it repeats itself. It repeats and keeps coming back in other kinds of problems continually in mathematics and physics and finance and lots of different places. All right, so in your calculator, if you take a quick look, there is a E button that's above. There's an LN button, third up from the side right there. You can see I've got it marked in red there, and then above that is an E to the X button. All right, that is this Euler's number. It's not Euler's number. It's Euler's number if I say it the right way. All right, so this is a number, all right? First of all, it is a number. It is an irrational number just like pi, okay? And it's a very special, unique number that appears in physics and finance and a lot of other different places in mathematics. It's sometimes called the natural number, like the natural logarithm. All right, so I got a couple things here. It's an irrational number like pi, all right? So pi is an irrational number that was discovered that relates the circumference of a circle to its diameter, all right? This is a similar kind of thing. What is going on here is when we graph this thing, y equals e to the x, at each point, the slope of the tangent line at that point is exactly the same as the x value. So at 1, at x equals 1, the slope is 1. And at 3, it's 3. And it goes all the way up through there like that. And it's the only thing that ever happens, only number that has that as a calculus property. All right, so we're not in calculus, obviously, but it's a calculus property. All right, so there's also a natural log. All right, a natural log, because there's the log base 2 and a log base 3 and a log base 4. The natural log, all right, where do I have that? Right here. Sorry, I'm reading my notes here. The natural logarithm, which is right here, is log base e. Okay, that's what that is right there, the natural logarithm. All right, and these are inverses of each other. So basically what we're going to have to be able to do, all right, bottom line is use our calculator to solve some of these things and also understand that when we flip these back and forth, which is the first thing in this file, all right, we're going to do it the same way. All right, and here I have this right here. We're going to do it the same way when we did the normal, I'm losing my train of thought, the normal conversions in the first things that we did this unit, which is actually 6.2 that I did it first in this unit. All right, so as an example, if I had s equals e to the q, when I change this, it would be log base e of s equals q. Exponent is always the answer in a logarithm function. Okay, but because e is a special number, we can replace log base e with n. Okay, to be honest with you, I very rarely ever used log base or ln when I was in math classes. I always just used log base e, and then when I put it in my calculator, I knew that I had to type ln instead of log base e. All right, I did it that way because it was just less to remember, and it was much easier for me to stick to the conversion things that I had done with other stuff if I did it like that. Okay, so we're going to talk about how to convert this. We're going to do a little bit of graphing with it. But really the important thing with this in particular is when we start solving equations, which we're like 2 days away from, all right, we're going to have to use ln and e to solve very specific kind of exponential growth equation.